Hello, and thank you for contacting Wave Support. I see from your request that you're struggling to get this lens wearable on the eye as well as trying to achieve some kind of vision. Well, if we look at your design for a moment, actually let's first look at your topography. As you know, you've got this central scar here in the right eye, as well as kind of an inconsistent or uneven area of steepness from the um, refractive surgery. So when I look at your design using GSIM, the main disadvantage of the GSIM in this particular case is that with such a difference between, say, the 2 o'clock, between 2 and 4 o'clock on the clock dial compared to, say, 6 to 9, superior versus inferior, you've got a little, quite a bit of variation around through here. So sometimes it's hard to get a lens to really match that as nicely as you can. So in those cases, I tend to like to switch over to freeform with the goal of trying to lay this lens out more consistently through the different meridians. So if we look at your design for a moment, if remember this green line on the top view is the corneal reference line, and if you follow take your radial control around and just kind of rotate around, two things you'll notice: centrally have a lot of area of clearance here within this optical zone, and it's also very inconsistent. So you have peaks and valleys through there. And then if we look at your landing zone, which is basically a blue to pink dot, you'll see that's also quite inconsistent. And that's one of the disadvantages we'll have with trying to do either a RSIM or GSIM with such an irregular cornea. And in this particular situation, since you have so much central corneal scarring, my guess is because you have this inconsistent area of clearance, you just aren't getting any real benefit out of the RGP to flatten out that scar over there or to even out the optical effect from that. That's probably also why when you put the left lens, which is basically a little flatter centrally onto that right cornea, you probably got a little more compression across its surface, smoothing out the irregular contour. So our goal is to try to bring that back surface lens a little bit more in line with the cornea. So the easiest way to do that is to switch over to freeform, and I did do a little quick design on that. What I did in this particular design, I kept the same diameter, I kept your same basic optical zones, and then I switched over to freeform and let Wave design that lens. And you'll see what happened very quickly. This lens centrally has come down quite a bit more, and if you look at your landing zone now, you've got actually a pretty nice looking landing zone through that area. A little bit of a couple peaks and valleys through there, but for the most part pretty nice. The other thing you may also notice on this design, if we look at the Wave design software, if you recall, the lower right corner of the quad view is the Wave interpreted topography. The lower left is the back surface of the lens, and if you look at your design versus the freeform design, you'll notice that the freeform back surface is starting to look a lot more like the front surface of the cornea. And so in this particular case, you would anticipate this lens to sit a little bit more nicely on there. So the next thing a lot of docs like to do is put a little aspheric component to that lens. If you'd like to try that, I find that there's no perfect predictability with that. I find it sometimes nice to try it, but I'm not. Sometimes I end up with just a basic freeform. But you'll notice if I redesign this lens, just putting a little bit of aspheric component to the design. I generally use about minus 0.05. You'll notice that all of a sudden this lower left design looks almost identical to the lower right. And now if we look at that corneal line, if you hit each radial all the way around, you'll see that you got a lens that aligns almost perfectly with the anterior surface of that cornea. So now you got a lens that will probably lie a little bit more consistently on this eye. I think by doing that, you're going to incorporate, you're going to be able to iron out a little bit of that irregular central cornea and be able to achieve some vision with this lens. Now, one little trick I like to use on all of my regular corneas like this, before I design the lens, I like to put a known RGP lens on the eye, something that a basic spherical lens with a known base curve and power. Just place it in the eye and try to keep it on the eye long enough to get an over refraction. Then I like to go down here to this tools section under trial lens data and just enter the lens that I came up with the over refraction. And what I find is this little helpful tool will help you get from point A to point B a little bit more efficiently. As you know, this Wave uses very complicated optics and calculations to come up with your final lens power, and sometimes having just a simple basic lens reference can be very helpful in getting you closer to that endpoint. Now, in your case, if you don't have that data, Well, actually, you kind of do have that data. So if we go over to your left lens, I'm going to pull that one up here for a minute if I can find it. Here we go. So your left lens, even though you did it in GSIM, if you wanted to try to use the data that you use for this one, if you click over to the RSIM on this left lens and look over here to the left side, you'll get sort of the spherical equivalent of your lens, which is a 1024 base curve with a plus 2.88 power. And if you notice, if you switch over and bring yours back up, your original design, this right one, if you go over and do the same thing on this right lens, you'll notice this right lens was a lot steeper. Then that would explain why you had such a larger area of clearance centrally. So I'm going to get that one out of the way. So if you take this little data and you go over to your tools and use your trial lens data, you can go over here and get it, enter it here. Well, we can at least get up to about a 10. And this would be about a 2 plus 288, or is it there? We'll go 275, a little bit steeper, since that's a little bit on this steeper than what you had there. And then you had an overfraction of -2 on that, I believe. And when you hit continue, it's going to add in that sort of over-refractive data that you had in this lens. And so sometimes you can use that if you'd like to add a little bit extra insurance to the final design. In your case, I may not do that right off the bat. Certainly you can try that, but I think if you just get a lens aligned a little bit more precisely, a little bit more closely to that overall corneal contour, that I think you'll have probably a little bit better refractive result right out of the gates. Now, I found sometimes in these unique situations, I found that I've almost had to go the full size of the cornea. In some of these cases, as you know, you've got a lot of stuff going on out here in this not too far from the landing zone. So sometimes if I can't get a lens to center or be comfortable or just lay nice enough, I'll actually take this diameter from about 9.8, I'll go all the way out to 11, sometimes almost the whole visible iris diameter. And I found in some cases I can get a very nice fit. Just a couple extra little thoughts. If you try this approach and you find that the lens is a little bit too tight on the eye, don't forget if you switch over to tangential, tangential will sort of flatten out that lens just about a half a diopter or so, just to make it a little bit flatter, so that way you don't have as much bearing in the peripheral areas. So I would probably try a couple of those little tips. You can use the same approach on that left lens to achieve a little bit more success. And of course, you'll probably have to go back and clean it up a little bit in the end with the final over refraction, but I think these tips will help you get a little bit more back on track. So I wish you well. Thanks for contacting Wave. This is a difficult case. Don't get discouraged. I wish you well, and have a great day.